Children, in our previous class we completed about chemical effects of electric currents, and in that we got to remember some of the liquids are good conductors of electricity, such as solutions of salt, acid and bases. They are good conductors of electricity. Then some are poor conductors of electricity, and to find if an electrolyte is conducting electricity, we made two different types of tester, one with a LED, and we checked the conductivity of electrolyte by using that. Then we made another tester with a magnetic effect of electric current, and it can detect very small amount of electric current also. Then we discuss about electrolysis. What is actually electrolysis? Electrolysis means it is composed of two terms. Electro means electricity, lysis means breakdown. Then chemical change. Chemical change means in a solution or a liquid, if there is new compound is forming, then that is a chemical change. Then electroplating. Electroplating means depositing on suitable metal over another substance, and its application also we discussed. Now we want to know some questions answers which is given here. First one, fill in the blanks. Most liquids that conduct electricity are solutions of dash, dash and dash. Most liquids that conduct electricity are solutions of acid, bases and salts. Once again, most liquids that conduct electricity are solutions of acids, bases and salts. Then question B, the passage of an electric current through a solution causes dash effects. The passage of an electric current through a solution causes dash effect. Answer is chemical effect. Which is the effect? Chemical effect. Once again, the passage of an electric current through a solution causes chemical effects. Then question C, if you pass current through copper sulfate solution, copper gets deposited on the plate connected to the dash terminal of the battery. Once again, if you pass current through copper sulfate solution, gets deposited on the plate connected to dash of the battery. See, in which electrode copper is get deposited? There are two electrodes we know. One positive electrode, another one is a negative electrode. That means the positive electrode is connected to, there are two terminals for the battery. This long line is positive and positive terminal, the line which is connected to the wire which is connected to the positive is called, and if this one is connected to an electrode, it is a positive electrode, and from this which electrode is connected, that is negative electrode. Now we want to find out in which copper is depositing. That means in positive electrode or negative electrode. We know copper sulfate, when breaks, it becomes copper ion and sulfate ion. See, this copper is a positive ion. Always this positive ion moves towards a negative. So copper is depositing on the negative electrode. Which electrode? Negative electrode. Negative electrode. See, if you pass current through copper sulfate solution, copper gets deposited on the plate connected to the dash terminal of the battery. That means negative terminal. That means it is called a negative terminal, and it is called what is a negative electrode. Negative terminal, that means connected to the negative terminal, and that electrode is called a negative electrode. Now question D. The process of depositing a layer of any desired metal on material by means of electricity is called. See once again, the process of depositing a layer of any desired metal on another metal by means of electricity is called dash. That is called what? It is called electroplating. What is termed electroplating? That means suppose we know what is gold depositing on some other less valuable metals to get the appearance of gold. That process is called what is electroplating. What is actually it is electroplating. Once again, the process of depositing a layer of any desired metal on another metal by means of electricity is called electroplating. Now we can go to the next question. Question number 2. When the free ends of a tester are dipped into a solution, the magnetic needle shows deflection. Can you explain the reason? When the free ends of a tester are dipped into a solution, the magnetic needle shows deflection. Can you explain the reason? See, in a tester there are two electrodes. That means in a tester there are two terminals. Suppose if it is a magnetic, it's two ends, there are two terminals. When these terminals dip into a solution, if it shows deflection means, this electrolyte is conducting electricity. This liquid is conducting, liquid conduct electricity. What is actually here we can, this liquid is conducting electricity. Otherwise, this liquid is a good conductor of electricity. Once again, when the free ends of tester are dipped in a solution, the magnetic needle shows deflection. Can you explain the reason? That means, to show deflection of this, that means electric current passes from its one terminal to other. That means here this solution helps to travel charge from one electrode to another. That means this liquid or solution is a conductor. This solution, the given solution is a conductor of electricity. The given solution is a conductor of electricity. That we can get from this observation. Now see question number third one. Name 3 liquids which when tested in the manner shown 14.9 may cause magnetic needle deflect. That means this is the picture given here. Here what type of tester is given? A magnetic effect using tester. Then here on battery, this is a solution. Now we want to find out name 3 liquids which when tested in the manner shown 14.4, that means this figure, may cause magnetic needle deflected. That means to deflect a magnetic needle, the solution must be a conductor. For this solution must be a conductor. We know conducting solutions. Example, let me say lemon juice. When we add lemon juice to water, that solution is a conductor. Or pure lemon juice, it is acidic in nature, so it is a conductor. And also another one is that is when we add salt, that means sodium chloride. Sodium chloride into water, that is also a good conductor. That means we know what is distilled water is a poor conductor, or otherwise it is not conducting electricity. But when we add sodium chloride to this distilled water, that also becomes a good conductor. So sodium chloride added to water, that is also a good conductor. Lemon juice is a good conductor, or vinegar also a good conductor. Now question is this: name 3 liquids which when tested by using this tester cause magnetic needle deflected. Magnetic needle deflected means the given solutions are good conductors. Examples for that are lemon juice, water, there is sodium chloride added water, and also vinegar solution, and another tap water and water from well. These are all conductors of electricity. Okay. Now we can go to next question. Question number 4. The bulb does not glow in the setup. List the possible reason. Explain your answer. Question number 4. Here on diagram is given. That is a battery, and here on bulb, and here on see. This is the question given here. The bulb does not glow in the setup. This given setup, bulb is not glowing. List the possible reasons. Explain your answer. First of all, this liquid may not conduct electricity. This liquid may not conduct electricity. That is the reason for not glowing the bulb. Another reason for this all, the connections made here are not we know what is a connection to this battery to bulb that are not tight. That means connections here may be loose. So that we want to make that loose connections. If there is any loose connection, that we want to make it to correct. That may also a reason for bulb is not glowing. First reason, this solution may not conduct electricity. One of the reason that we can take. Another reason, these connections here we made is not tight, or the connections are somewhere, the connections may be loose. Due to loose connection also bulb may not glow. Then another reason for this, even though this solution conduct electricity, even though this solution conduct electricity, that electricity is not sufficient to get heated up the filaments to emit light. That much is not getting heated up. That means here it conduct a very small amount of current. That current is not sufficient to get heated up this filament to emit light. So this solution is conducting, but due to feeble current, the filament may not get sufficiently heated up. That also can be a reason. You want to remember some 2-3 reasons. One, the connections may be loose, and another one, the liquid may not conduct electricity. That means it is a poor conductor of electricity, like distilled water. Sometimes what is the solution is conducting, but that current is feeble. That means what is the meaning of feeble? Means very small current is flowing, but that small current is not sufficient to get heated up this bulb's filament so that it can emit light. That means here the current is not much enough. That also the reason for the bulb is not glowing. These are the things we can take for this answer. That means why the bulb is not glowing. Sometimes the bulb may be fused on also. If the bulb is fused on, then also what is the bulb is the bulb will not glow. We can take a different reason. Sometimes the bulb is not good. That means if the bulb is fused, then it does not glow. Then if there is any loose connection, then also it is not possible. Or if the solution conduct a very small current, then also not sufficient for the bulb to glow. Then sometimes the solution is not a conductor of electricity. These are the reason for the given question. Next, now we can go to question number 5. A tester is used to check the conduction of electricity through two liquids labeled A and B. There are two, A and B. See, a tester is used to check the conduction of electricity through two liquids. First liquid is A. Second liquid is B. Conduction of electricity two liquids labeled A and B. It is found that bulb of the tester glows. It is found that the bulb of the tester glows brightly liquids A, while it glows very dimly for the liquid B. You would conclude that, see, this liquid A, here the bulb glow brightly. canister which we placed in liquid B, in that case bulb glow dim. That means dim. That means very faint. Now here 4 answer is given. From this itself you can understand what is if the bulb glows, if the bulb of the tester glows brightly, means this liquid conducts electricity very well. But here the bulb glow dim means it does not conduct electricity properly, or its conduction is electric conduction is less than that of A. See now the answer given here, liquid A is a better conductor than liquid B, which is the answer given first one. Liquid A is a better conductor than liquid B. Liquid B is a better conductor than liquid A. Is it correct? Then both liquids are equally conducting. If both liquids are equally conducting means in both cases the bulb will glow brightly, or both cases bulb must be dim. Conducting properties of liquids cannot be compared in this manner. Now here 4 answer. Among that first one is the bulb in the liquid A glow brightly, means that is a good conductor, and this liquid B is a not so good conductor. So the answer is liquid A is a better conductor than liquid B. Liquid A is a better conductor than liquid B. Now we can go to the next question. Question number 6. Does pure water conduct electricity? If not, what can we do to make it conduct? Question is this one. Pure water is a conductor. If not, what can we do to make it conduct? See, pure water means it is a distilled water. All other water that we obtained from what is a well, tap, a river, rain. In this all there what is some impurities. Impurities means some dust or salt dissolved. In this all, that means water from well, water from tap, water from river, rainwater. In this all, certain kind of salt is dissolved. Certain kind of salt, dust and clay etc. are present in this type of water. But pure water means distilled water. In distilled water we know there is no salt or any other things dissolved. So it is a bad conductor or it is not conducting. So to make this distilled water conducting, what are the ways we done in our class? Add some salt. Salt means some sodium chloride or any salt. When dissolved this water, this distilled water we can make into a conducting solution. So to make a distilled water into a conducting solution, what we can do? By adding certain salt or some acid, instead of some salt, if you add some acid, that is lemon juice, then also this distilled water become a conductor. Or instead of some acid, some base, sodium carbonate or calcium carbonate etc. if we add, then also this distilled water become a conductor. So to make pure water to a conductor, to make pure water to a conductor, there are different ways. By adding some amount of salt or some acid like lemon juice or vinegar or any other kind of acid or tartaric acid or citric acid or anything, if you add then this become a conductor. Or adding some base, sodium carbonate, caustic soda, potassium carbonate, etc. Anything if you add, then also this become a conductor. That is the different method. But these are all, even though we think that means we take water from well to drink, we think it is pure, but actually it is not a pure water, because in the well water or tap water or river water or rain water, some other salts also dissolved from their environment. Okay. Now we can go to question number 7th one. See question number 7. In the case of a fire, before the fireman uses water hoses, they shut off the main electrical supply from the area. Explain why they do this. See, in the case of a fire, before the fireman uses water hoses, they shut off the main electrical supply from the area. Explain the reason for this. We know the reason. That means water is a conductor of electricity. We know water is a conductor of electricity. But if we use, that means if the fireman uses water hose without off the electric supply or main supply, that means they may get what is electric shock. They may get that means when the water is pumped, that water and water come in contact with the electric lines, and when through that water electricity can flow through, in that way what is those who are near can get, that means those who touch the water can get what is electric shock. So that to avoid this kind of electric shock, they switch off the main. That means when the main is switched off, there is no current, then there is no chance of getting electric shock. So to avoid, that means water, we know, is a conductor. Water from the hose, when pumped, that water may come in contact with electricity, and through that water electric flow may take place, and persons can get electric shock. To avoid that, they off the main supply. And now question number 8th one. See, a child is staying in a coastal region, tests the drinking water and also sea water with his tester. He finds that the combustion rate reflects more in the case of sea water. Can you explain the reason? See, one sample, he used drinking water. Another sample, sea water. That means in the first sample, that is the drinking water or water from well or water from tap, that when tested, deflection of the tester is less. But here deflection is more. Because we know when comparing with the drinking water, in the sea water, salt dissolved is more. More salt is dissolved there. When the salt amount is more, the conductivity of this seawater is more. That means seawater is more conducting than what is drinking water. That means conductivity or seawater is a good conductor than that of what is drinking water. That means this will pass electric current more easily than drinking water because in it more salt dissolved. Salt helps to conduction of electricity through solution because salt dissolved it easily ionizes. That ions are the helping for conduction of electricity through the solutions. Okay, now we can go to the next question, question number 81. A child is staying in a coastal region test. Okay, that is 81. Now 91. Is it safe for the electrician to carry out electrical repairs outdoors during heavy downpour? Explain. That means heavy downpour means very big or heavy rains. During rains, you know what is the surrounding is or atmosphere is filled with their atmosphere is with the water. Or also there is chance to get the appliance to get wet. That means the appliance may get wet and that may leads to electric shock. But inside means there is no chance to get the appliance to wet because there is no chance of getting electric shock. That is, so the answer is that is it safe for an electrician to carry out electrical repairment outdoors during heavy downpour? Explain. It is not safe. It is not safe to repair electrical appliance outside during heavy rain. Why? Because during heavy rain there is chance to get the appliance to wet, and that may leads to, that means we know water is a conductor of electricity. That means even though when we touch its body part, water passes through the body part to inner part of the appliance, and from there current may leak to the body parts and the person can get electric shock. Okay. Now question number 10th one. Paheli had heard that rainwater is as good as distilled water. So she collected some rainwater in a clean glass tumbler and tested it using a tester. To her surprise, she found that the compass needle showed deflection. What would be the reasons? That means we know what is rain is formed due to distillation of water. That means water vapor. Actually water vapor when cooled it is the rain. Now distilled water also we get what is vaporizing water. Now why rainwater becomes conductor but distilled water is not a conductor? Both are obtained from distilling, but when the distilled water or the vaporized water from cloud comes down, there is so many what is dust and other chemicals in the atmosphere, and when these chemicals dissolved in this rainwater becomes a conductor. That means in the atmosphere there is dust, chemicals and certain gases also. When dissolved in it they become conductor, but distilled water is not a conductor because in it there is nothing is dissolved. In distilled water no material or no substance or no salt is dissolved, so it is not a conductor. But in rainwater there are so many gases or dust particles or salts, acids, etc. can be dissolved, so it become a conductor. Now question number 11 to 1. Prepare a list of objects around you that are electroplated. For that you want to make a list. That are the things. What are the things, your surroundings that are electroplated? For that we want to make a list. Suppose that all we come across, which are they on bicycle hands. This one is electroplated. Then another one, water tap, especially used in bathroom, etc. Not plastic, other one. There also water tap also electroplated. Then gold plated ornaments. Gold plated ornaments, that also we can see around or from our house or some nearby persons. Then silver plated ornaments also available. Silver plated ornaments also available. Then copper plated, that also we can get it. And some other thing. These are all we can get from our surroundings or observing from our neighborhood. We can get this all. And also a rim of what is a cycle, car, wheels rim. These are all electroplated. Now next question, question number 12. The process that you saw in the activity 14.7. Activity 14.7. See the activity 14.7. That means copper sulfate with the electroplating. That means copper plate, copper sulfate solution. That is the 14.6. This one. This is the activity 14.7. Here also copper sulfate solution. Copper sulfate solution. Now we can go to the question. The process that you saw in activity 14.7 is used for purification of copper. Here this activity is used for purification of copper. A thin plate of pure copper and a thick rod of impure copper are used as electrodes. Instead of this, we are going to what is a thin plate of pure copper. Here we are using thin plate of pure copper, and copper form once again a thin plate of pure copper and a thick rod of impure copper. Thick impure copper. impure copper as electrodes. Copper from impure rod is sought to be transferred to the thin copper plate. Which electrode should be attached to the positive terminal of the battery and why? That means here we using two electrodes. That means in the activity both we use copper plate, but here we are going to use see, one is a thin plate of pure copper. In this we want to get deposited pure copper, and another one is thick impure copper. Thick impure copper. Here among these, which electrode you use as a positive electrode and which will take as a negative electrode, that we want to find out. The electrode in which the metals we want to get deposited. In which electrode we want to get deposited pure metal, that we should take negative. So here we see this one is the negative, this is positive. The electrode connected to this negative is called negative electrode. So here we take as a pure, here this will take as a pure copper plate. This will take us pure copper plates. Okay. Then another one is the thick impure. That we take as a positive electrode. So this will be thick impure plate. That will connect it to positive. Thick impure plate is connected to positive. So this one is here we know the reaction copper sulfate here break into copper ion and sulfate ion. Copper ion from this go to this negative electrode and get deposited in this negative electrode, that means pure copper plate gradually become what is thick and thicker, but this will gradually, its thickness gradually decreasing. Okay, this is actually happening. So thick plate we want to take that is thick impure plate we want to take as positive or connected to the positive, and this one will be connected to the negative. Okay, now from this exercise we completed all the questions. Okay, with this we can close today's class. Now we can start with the next lesson in another class. Thank you.